Hey everybody, it's Ripley back again. Today we're going to talk about lines tangent to curves. And let's talk about why this is important. All right, so back in the day, before people really knew what calculus was, or before they had invented it / discovered it, they had functions. Let's call this x and f of x, okay? I've got this function that's cruising like this from some point here at A to some other point here at B, okay? And they were interested in a line tangent to the curve at, say, point A. So let's throw a little color on this bad boy. Call it this point right here, which is going to be A comma f of A, right? And they were interested in the line tangent to that curve. So let's make the line tangent to the curve, this little red guy right here. And you may say, well, Ripley, why? Why would that be important? Well, let me show you really quickly. If you think about it, if you've got a position function, so I've got some t, and let's say, I don't know, the height of a ball thrown, right? So I throw a ball from some initial height, h sub 0, and that ball goes like this, right? Got some sort of ballistic thing going on here. All right, excuse me. My nose is a little running. All right. Now, what didn't take mathematicians and physicists long to figure out is if you could figure out what the slope of the line tangent to the curve was, then you could turn a height function into a velocity function. If you could figure out all the slopes of all these lines tangent to the path of this object, then you can determine the velocity of the object at any point t. That's relatively important if you think about it, right? That's pretty cool because they already knew how to determine height functions, right? You got this parabolic path, excuse me, in terms of rectilinear motion, right? But what they needed was to be able some sort of mechanism, some sort of algorithm, some sort of process by which they could figure out what the slope of the line tangent was. Well, that process is called a fishing expedition. And we'll get into the actual mathematical mechanism by which that's done. Now, it should be relatively easy to see that if I draw a line from, let's see, this is going to be A f of A to B f of B, and you'll probably remember this from your pre-calc, that the average rate of change, all right, the average rate of change, I'm going to use a little delta just to get you physicists all happy with me, or the average slope from A to B is f of B minus f of A over B minus A. Now, here's a word, okay? Another word that we have is called the slope of the secant line. This line is referred to as a secant line, not to be confused with the secant that we used in trig, but they definitely have some things in common. All right, it's the same thing. But what I want is the slope of the tangent line. Now you may be going, Ripley, I'm starting to see some overlap here between my trig stuff and now this calculus stuff, even though this doesn't have anything to do with right triangles. Well, you're right. Okay. Now, but we don't want to get into the language of it right now, the etymology of all the words. What we do want to do is figure out how to get to a tangent line. Now, I call it a fishing expedition because what you do to determine the slope of a line tangent is very much like fishing, where you throw out a lure and then you reel it back. We throw out a lure, okay, and we make this secant line, and then what we do is slowly but surely bring these points back as arbitrarily close to A f of A as we possibly can. So what's happening here is we've got, well, bam, we got that line, then we got that line, and 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 then we got that line. Those are all secant, right, lines, and we know their tangent, or excuse me, we know the slopes of all of those secant lines. And as I draw this point back, as I bring B back to A, what I end up with is, when I'm really close, if I were to zoom in on that, if I get close without touching, because notice if I touch, I'm screwed, right? Because then I'm going to have f of A minus f of A over A minus A, which is 0 over 0, which is bad. But if I get so close to A f of A that I can't tell the difference, then what I will get is the slope of the tangent line. So instead of having this slope of the secant line, this guy will turn in to the slope of the tangent line. Now you will hear me refer to this as this fishing expedition. The problem is we need a mathematical mechanism by which to do that. And you've played with this a little bit in pre-calculus. It's something called limit, which we will talk about in the next section. But what we're doing is we're taking the limit as B approaches A, as we head back to A, of this guy right here. The whole thing starts with the slope of a line. Believe it or not, this is going to make you giggle, or it may make you nuts. All of differential calculus, every single piece of differential calculus simply has to do with the slope of a line. Ladies and gentlemen, we've been dealing with slopes of lines, historically speaking, for probably 5,000 years, since the pyramids were built, right? They knew what slope was. And yet, it took them almost 5,000 years to be able to turn this into what we now refer to as differential calculus. All right, so again, in a quick little recap. The whole reason that people wanted to figure this out is they were starting to figure out in physics that it would be really helpful to determine the velocity of objects in flight, or the velocity of objects, I don't know, cruising along a line, right? And they started with position graphs, which were relatively easy to figure out, and then they wanted to be able to get from a position graph to velocities at any point along that, which this velocity, if you think about it, represents instantaneous rate of change, which is the slope of the tangent line. Okay? So average rate of change, slope of the secant line. Instantaneous rate of change, slope of the tangent line. All right. That's enough. That's it. That's all I got for you. So that makes it pretty easy for everybody, right? Yeah, I'll see you in the next section where we start talking about limits, which is the mathematical mechanism by which we are able to determine these slopes of lines tangent. All right, see you soon. Have a good day. Bye.